Hi everyone, welcome to my channel Ravi Babu Edu Tech. Today we are going to cover full wave rectifier derivative part, which means we are going to calculate efficiency, ripple factor. So these are the major parts which are going to calculate in that full wave rectifier. So how to calculate those values in the sense, let's analyze the input, mathematical analysis. See, this is a mathematical analysis. What is the input voltage is given? Vm equal to, that is V equal to Vm sin omega t. This is my input applied voltage. Then the output current existing, that is I equal to Im sin omega t for 0 less than equal to omega t less than or equal to pi, whereas I equal to same current which is passing between pi to 2 pi. Similarly, pi less than equal to omega t less than equal to 2 pi. So what do you understand from here? So due to two diodes are rectified, that is D1 is on condition and D2 is off condition. In that here D1 is on, okay, and D2 is also on. Like that it will be rectified continuously based on the D1 and D2. So this is what rectified continuously output waveforms which are occurred here. So from 0 to pi current will flow, again pi to 2 pi current will flow. So it will be continuously current will be flowing. So that I am going to consider only 0 to pi. So not required pi to 2 pi, because everywhere the same current flow. So that I am considering only 0 to pi. So this is the first case I am going to consider to finding the values of what is the load voltage, what is the load current, then what is the input voltage and input current. We are going to calculate all these values. Then only it is easy to calculate efficiency as well as ripple factor. Okay, first let's discuss about VAC, that is Vrms. Okay, so Vrms is nothing but root mean square voltage. So Vrms is nothing but root mean square. So I am going to take input voltage is going to take squaring of that value. So here I am going to take square root of then 1 by pi integral 0 to 2 pi V into 0 to pi, then V square into d omega t, that equal to Vrms equal to square root of 1 divided by pi integral 0 to pi, because here what is V? Input voltage, that is V equal to Vm sin omega t. Now in place of V square you should substitute Vm sin omega t whole square into d omega t, that equal to 1 divided by pi integral 0 to pi. So this value should be taken as Vm square sin square omega t d omega t. Okay, so after that this Vm square get into the outside, Vm square divided by pi integral 0 to pi. What is the expression here? Sin square omega t d omega t. This is the expression remaining. Now for simplification I am going to consider this expression, that is, as you know, according to trigonometric equation, cos 2 omega t equal to 1 minus 2 sin square omega t, where theta equal to what? Omega t. So that I am taking omega t here. Okay, now this expression can be written as 2 sin square omega t equal to 1 minus this term get in RHS, that is cos 2 omega t. Okay, so here for simplification this sin square omega t, then cos 2 omega t equal to 1 minus 2 sin square omega t. Now this 2 sin square omega t equal to 1 minus cos 2 omega t. Okay, where omega t is nothing but I am considering theta equal to omega t. Okay. Right. So two sin square omega t equal to 1 minus cos 2 omega t. Now these two get into the RHS. Sin square omega t equal to 1 minus cos 2 omega t divided by 2. Hope you understand. Now this step I am going to substitute in that above equation, that is here in place of sin square omega t I am going to substitute this expression. So Vrms equal to square root of 1 by, that is Vm square by pi integral 0 to pi. So in place of sin square omega t we have to substitute 1 minus cos 2 omega t divided by 2 into d omega t. Okay, now this will be getting Vm square divided by pi. So this d omega t get into the multiply this expression, and this 2 also get into the outside, that is 2 pi. Now integral 0 to pi 1 minus cos 2 omega t into d omega t. Okay, this 2 get into the outside. Now what we'll do, Vm square divided by 2 pi integral 0 to pi multiply with this term. So multiply this term 1 minus cos 2 omega t, d omega t is there, right? So d omega t multiply with this term, what will get it, d omega t minus cos 2 omega t into d omega t. Okay, now you should apply integration with respect to omega t. So Vm square divided by 2 pi integral d omega t omega t. Okay, so if you know the concept about integration and differentiation, accordingly I am applying here. So integration d omega t minus integration cos, that is sin 2 omega t divided by, here constant is there, that is you will get 2 integral, that is 0 to pi. Okay, now so after integration this expression you have to substitute upper limit minus lower limit. So Vm square divided by 2 pi integral, so upper limit is what, pi, minus this sin 2 pi divided by 2, this is upper value, minus 0 minus this is also 0. Okay, so we have to substitute here, sin 2 pi is nothing but 0, so this total will be 0. Okay, now Vm square divided by 2 pi, so this value, this is sin 360 which means 0, so this term also 0, this total term becomes 0. So what is the final expression you will get it, Vm square divided by 2 pi into pi, so pi get cancelled, that is Vm square divided by 2, that equal to square will be cancelled in the sense what, that is Vm by root 2, that is what, Vrms. Okay, so that is the conclude of Vrms value in full wave rectifier. Vrms is equal to Vm by root 2, that is what input AC voltage, that is Vrms also can be written as VAC. Okay, so thank you for watching my video. If any doubts regarding this derivative part, please feel free to contact me. Thank you.